Hi everyone, my name is Miles and I'm one of the SIs for Chem 1B this quarter. Today we're going to go over oxidation numbers and redox reactions. Specifically, there's just one question discussing balance and redox reactions in a basic solution. So let's just jump right into it. Okay, and here's the question. And then prior to me recording this, I wrote out just the steps on the left side just to follow along and create an outline. So the question is asking us to balance this reaction below. So the first thing you want to do, given the steps on the left, is just to determine the oxidation and reduction atoms. So what's getting reduced, what's getting oxidized. So we do that by oxidation number. So the oxidation number of silver in this case is going to be 0 because it's by itself. The oxidation number of Cn minus be -1 because it states it right there. And the oxidation number of oxygen is also going to be 0 because it's by itself. And then move on to the right side. We know from previous reactants right here on the left side that the oxidation number of Cn is always -1. And there's 2 of them, so that means we have a total charge of -2 for the Cn. And if we look here too, you can see the -1 charge is the net charge of the whole molecule. So that's the charge we need at the end. So to get a net charge of -1 and we have a -2, we need silver to have a +1 charge right here. Awesome. So now we can determine what's oxidized, what's reduced. So in this case, what's oxidized is going to be silver, because silver is going to go from a 0 to +1 charge. So that means it's going to lose electrons and become positive. And then what's getting reduced? You can see the Cn doesn't actually change charges. It stays at a -1. So that can't be it. So the only thing that could be reducing is the oxygen. So that means it's gaining electrons. Okay, awesome. Now we want to break up the reaction into the half reactions. So we have oxidized, and then reduce. So the oxidized, that's going to be Ag plus Cn minus, creating Ag Cn2 minus. So first you want to do, according to the steps on the left, and what we're going to follow, is we're going to balance the atoms that are not hydrogen or oxygen. So you can see on the left side we have 2 Cn, so we want 2 Cn on the right side too, to balance out. Awesome, and then the silver's already balanced. Okay, awesome. So now there's no need to balance any hydrogens or oxygens because there's none in there. So the next thing you want to do is just balance the electrons in. So, balance the charge. So we could see the charge on the left side, it's going to be -2. And charge on the right side is -1. So that means to balance this, we need to add 1 electron to the right side. So plus electron. So now we have a charge of -2 on the right side. Okay, perfect. So now the oxidation is all balanced. The oxidation half reaction, because we balanced the charge. So next is going on to the reduction. So that's going to be O2. As you can see, there's nothing on the right side in the initial reaction. So what we're going to have to do is we're going to balance it. So to balance the O2 and any oxygen, you want to add water. So since there's 2 oxygen on the left side, we want to add 2 H2 on the right side. So now we have 2 oxygen on the right side. Okay, afterward, you want to balance the hydrogen. So since we have 4 on the right side, we want to add 4 more on the left side. Perfect. So now all the hydrogens are now balanced. Perfect. And if we look at the charge, we can see that this has a +4 charge, and this water has a net charge of just 0. So now we have to balance the charges. So we can do that, since it's a basic solution, we can do that, and we want to do that by adding the OHs instead, because the OH has a negative charge of -1. So we're going to add an OH 4 OHs on the left side, and then we're going to add 4 OHs on the right side too. And the reason we do that is we want to keep the atoms matched up on both sides and have equal numbers on both sides. We just want to change the charge. So by doing this, we change the charge, but we keep that same amount of atoms on both sides. And then by doing that, we can add right here to make 4 waters. Perfect. And now we can cancel out the waters on both sides because we have 4 on the left side and 2 on the right side. So we can totally get rid of this one and change this one into a 2. Okay, perfect. So now the charge on the left side is going to be 0, and the charge on the right side, -4. So now since everything is balanced and we added the OHs because we have to add the OHs and use them, this is a basic solution. And basic solutions have a predominant amount of OHs. So that's why we can't just use the hydrogens themselves. If we could, it would be an acidic solution, but it's not an acidic solution in this case. It's going to be a basic solution. So to balance the charge in this case, in this one, we're going to add the electrons to the left side. So since we have a charge of -4 on the right side, we should add 4 electrons to the left side. Perfect. So now we have 4 electrons on the right side. Now everything is balanced because this creates a charge of -4. Perfect. So now both reactions are balanced in charge and atom count. So now we want to add them together. But before we do that, we need to make sure that the electrons have to cancel out. So since we have 4 electrons in this reduction reaction, that means we need 4 electrons in this oxidation reaction. So we need to multiply the whole oxidation reaction by 4. So that means we have 4 Ag plus 8 Cn minus going to Ag plus 4 electrons. So this is the ox, and now I need the reduced. So now we're going to move the reduced right over. Okay, perfect. So now we can add these two reactions together to get a total net reaction. So right away we can cancel out the electrons. Kind of awesome. And then that looks like that's all we can cancel out in this case. Yeah, it looks like all we can cancel out in this case. So we're just going to add them two together. So on the left side we have Ag, Cn, H2O, and O2. So you have 4 Ag plus 8 Cn minus plus 2 H2O plus O2. And that's going to go into and create products of 4 Ag Cn2 minus plus 4 OH minus. And then right here, that is the total reaction, net reaction, balance reaction of this redox. So that's it. Thank you all for watching. If you have any questions, feel free to comment below. Good luck studying in your studies, and I wish you the best. Thank you.